the last lectures, we discussed there the descriptive measures of association. Descriptive measures of association. We discussed two descriptive measures of association. The first one is the coefficient of determination, which is R squared, and which is equal SSR over SS total. And we said that this coefficient measures the reduction in variation of y when x is used. For example, if r squared equal 20% or 0.2, this means that the variation in y is reduced by 20% when we introduce x, or when x is introduced. Okay? This is, and also we explained why this coefficient measures the reduction of variation in y. This is done in the last lectures. Also, we discussed the other descriptive measures of association, which is called coefficient of correlation. The coefficient of correlation is small r, which is equal plus minus square root of r squared. If the slope of the regression line is positive, then the coefficient of correlation is positive. And we said that if the slope of the regression line is negative, then r is negative. Also, we write the formula for r in this way: a summation of yi minus, or first xi minus x bar times yi minus y bar over summation of xi minus x bar squared times summation of yi minus y bar squared under the square root. We said that r is used to measure the linear association between x and y. This coefficient is used to measure the linear association between x and y. I want to show you that how this coefficient, or how this formula can measure the linearity between x and y. Let us look at the following scatter diagram. We have x here, and the predictor and the response variable y in the y-axis. Let us divide the first quarter into 4 equal parts like this. This point is x bar. You know, x bar is a measure of central tendency, so x bar is in this at this point. Also, y bar is at this point. Okay? The value of x, which lies in this line, okay, are less than x bar. So we have in this part, we have xi minus x bar is less than 0. Also, we have yi minus y bar in this part. Yi minus y bar also is less than 0. In this part, we have xi minus x bar is greater than 0, but yi minus y bar less than 0. We have here xi minus x bar greater than 0, yi minus y bar is less than 0. In this part, we have yi minus y bar is greater than 0, but xi minus x bar is less than 0. In this part we have xi minus x bar greater than 0 and yi minus y bar greater than 0. Did you understand this point? Any questions?
No.
Okay. Now, if xi is close to 0 and yi is close to 0, what do you think about the scatter plot will be? Did you understand? Now I have the set of data points x1, y1 up to xn, yn. Assume that xi is close to 0 and yi are also close to 0. What do you think about the relationship between x and y? Again, we have xi are close to 0 here in either side. Xi are close to x bar in either side. Also we have yi are close to y bar in either side. That means that xi are, or the data points are concentrated in this area. Do you agree? When xi and when xi are close to sorry, I want to say that xi minus x bar close to 0 and yi minus y bar close to 0. Okay? Or xi close to x bar. So we have this kind of relationship between x and y, which is not linear, So in this case, we don't have a linear association between x and y. Look at the other case. If xi minus x bar less than 0, okay, but yi minus y bar is close to 0. What do you think about the relationship between x and y in this case? Xi minus x bar is less than 0 or are far from 0. Are far from 0. Xi minus x bar. That means x's points are, there is a variability in x. Okay? But xi minus x bar are close to 0. So we have this kind of relationship. Which kind of relationship? We have data points like this. Like we have horizontal line. Horizontal line. That means there is no linear association between x and y. Also in this case, we don't have a linear association between x and y. Okay, the third case, did you understand this point? Again, xi minus x bar are far from 0. So we have variability in x's, in the x-axis. But yi minus y bar are close to 0. Okay, or yi are close to y bar. That means the variability in y is very small. Okay, so we have this kind of relationship between x and y, which is not linear. Or we say that there is no linear association between x and y. Okay. The third case, if xi minus x bar is close to 0, but yi minus y bar is far from 0.
Vertical line.
We have a vertical line like this. The data points are concentrated in this way. So again, we say that there is no linear association between x and y. Fourth point is if the remaining one. What is the remaining one? Xi minus x bar are far from 0, and also yi minus y bar far from 0. Both of them are far from 0.
Linear
Okay?
relation.
There is linear association like this. Xi in this way. Similarly, if we say xi minus x bar greater than 0, far from 0 from the other side, and yi minus y bar greater than 0, we have this the negative one in this way. So the only case that we get a linear association between x and y is xi minus x bar. This is far from 0, so there is a variability in x and there is a variability in y. Here also, xi minus x bar greater than 0, far from 0, so we have variability in x and variability in y. In this case, we obtain a linear association in x and y, or between x and y. For that, if you look at the numerator of this factor, or this formula, we see that the sum of xi minus x bar times the yi minus y. How much this is large, that means how much we have a linear association. For that, this coefficient of correlation is used as a measure for linear association. We divide it by the square root of the variances in order to normalize the formula. Or, you know, we have summation of xi minus x bar times yi minus y bar. This is an indicator for the linearity association between x and y. Okay. By Cauchy-Schwarz inequality, you already know. Do you know the Cauchy-Schwarz inequality? Cauchy-Schwarz inequality. This is a case of Cauchy-Schwarz inequality. This is less than or equal. Let me write it here. Summation of xi minus x bar times yi minus y bar square is less than or equal. Summation of xi minus x bar square times summation of yi minus y bar square. This is called Cauchy-Schwarz inequality. Cauchy-Schwarz inequality. Now divided by this term, we obtain summation and take the square root. Okay, we obtain summation of xi minus x bar times yi minus y bar over square root of summation of yi minus y bar, the same, xi minus x bar times summation of yi minus y bar square is square. This is less than or equal 1 in absolute value, because the square root of the square is the absolute value. For that we, if you remember, we write that R, this is the coefficient of correlation R, is its value is between -1 and